6.5 Example 4. In Example 4, we're going to look at when the population P is growing the fastest. And as a function of P, we have that dy dp is equal to kp times n minus p. So let's just talk about what it means to be the fastest. So the first derivative tells us the rate of change of something. And the second derivative is going to give us the maximum or the minimum of the first derivative. So by taking the second derivative, we can find the max of the growth. Because the growth rate is the first derivative, and I want the maximum growth rate. So I'm actually looking for this second derivative. So this is actually pretty easy to do. So we start with our first derivative, which is dy dp is equal to kp times m minus p. Now remember that k and m, these are constants. So before I go ahead and do this, I'm going to distribute this kp into the function. So I get dy dp is equal to kmp minus kp squared. Okay, so now I go ahead and I take the second derivative, and this just becomes km minus 2kp. Again, we're taking the derivative with respect to p, so this is our only variable. Now if I want to find the maximum growth rate, I'm going to set the second derivative equal to 0. So km minus 2kp, and I'm going to go ahead and solve for p. So I'm going to add the 2kp to both sides, and I'm going to divide by 2k. So I get p 2 is equal to, the k's cancel, and m over 2. And you're allowed to divide by k because it's a constant. And keep in mind that m is the carrying capacity. So we have that the population is growing the fastest when the population is half the carrying capacity. So again, you grow the fastest when you're half the carrying capacity, which is the m over 2. And you're really going to want to go ahead and memorize this. That's just something you want to know, that the population grows the fastest when you're at m over 2.